Hi everyone. Good afternoon, guys. Good afternoon, everyone. How are you all? Everyone, how are you? Hope you're all doing well. All of you had your lunch, everyone. Everyone had your lunch or not? All of you. Right. So here we'll be continuing our discussions on this. Right. What is it you can say? That structural analysis crash course we are discussing now. So all of you had your lunch, everyone, or not? Yeah. Good afternoon, Shruti. Right. Everyone had your lunch or not? Lunch over? Right. So here we'll be continuing our discussions on which one? This one, na? Yes or no? Yeah, Vishal. Good afternoon. Arey yaar, it is not going live. 1 second. Yeah, now it is going live. 1 second, guys. Yeah. So here, Brahmastra batch 2 for this GATE 2024 structural analysis, right? So up to yesterday, what we have completed, if you remember, we have completed this static indeterminacy and this kinematic indeterminacy we have completed now. And now we'll be doing which one you can say, and now we'll be doing which one you can say that is stability of these structures will be doing, right? Is not stability of these structures will be doing, right? So these are all ESC Civil 2023 toppers, right? Congratulations. Now, so we'll be having the latest batches started on which one? This is November 30th, all of you. That geotechnical engineering was started by Amit Jarola sir. So don't miss this. RP civil is the code you have to use, right? It is not a roller, it is internal roller, okay? It is internal roller you are asking about. Are you asking the same? So for 2025 also that same batch will be starting, right? Every day at 6:30 p.m. you'll be having the classes, right? Are you asking about the internal roller? Is it so? So this is which one you can say? Yesterday's class or which one? Where we have taken m minus 1? No. Where did I take f equal to m minus 1? No. Only for internal hinge we have taken that m minus 1. Are yaar. Only for which one we have taken m minus 1? Internal hinge we have taken that m minus 1 or m dash minus 1, right? That is meeting. So this is which one? No cost EMI option is also given by Unacademy. You can just go with this, right? 0% interest on your no cost EMI. Now these are all GATE 2023 toppers. Congratulations for all of them. This one is over. Second chapter is also we are getting now. So mostly it will be over today. Right, static indeterminacy, kinematic indeterminacy, and stability of the structures. Right, second chapter only we are discussing here. Now, so what are your doubts? Yeah, so you are see whenever you want force release, number of force releases. Suppose if you observe here now, what is the number of this force releases here? You can say that is m dash minus 1. How many number of members are meeting here? Tell me. How many number of members are meeting here? Tell me. 4 members are meeting. Na? That is your 4 minus 1 equal to 3 you are having. Okay. And so whenever this one is there, na, how many forces will be considering? How many will be considering? Here you can say this is 4 minus 1, 3, right? Yeah. You are talking about the degrees of freedom or you are talking about the force releases? Tell me. Are you talking about the degrees of freedom or force releases? Tell me. Shruti. Don't mix both. Yeah, Deepa, good afternoon. Yeah, force release here will be what? One force release, right? Yes, na? And here, if you just observe it, here also, how many forces will be released? You can say plane structures only we'll talk about, right? Here also, one force release, right? This is force release. This also, which one? This is a force release only, right? And whenever you are having this internal link, right? This kind of this internal link is there, na? Or this kind of which one? This internal roller will be there, right? Internal link or this kind of this internal roller. So what is that a force release will be having? You can say 2 forces will be released, right? Not 3, right? What are the 2 forces released? Tell me. One is your, what are the 2 forces released, right? One is your moment force is released, right? Why moment force is released? Because rotation is allowed, na? And axial force, right? Moment force plus this axial force, right? These two are released, you can say, if you just observe, right? These are the force releases, right? For this plane structure, okay? For this plane structure, okay? Done? Clear now? Your doubt got cleared, Shruti, or not? Your doubt got cleared? Where I have written 3? When I have written 3? Under force release I have written 3. Is it so? For which one I have written mostly? Yesterday. Yesterday's class where I have discussed the force releases, ma? That is what again I am asking same thing. You are talking about the force releases or you are talking about the degrees of freedom? Here degrees of freedom will be equal to which one? 3 plus a number of the force releases. That is what? Okay. Yesterday's class is not force releases. It is the degrees of freedom, right? It is the degrees of freedom. It is not the force release related, right? It is not the force related force releases, right? It is the degrees of freedom only. You have to be careful, right? Here degrees of freedom is equal to which one? 3. Why 3? Because of this member, one joint is created, na? Is that no? Because of this member, one joint is created. So 3 plus force release. Now clear? The difference is clear. The difference is clear. The difference is clear. Is the difference clear? 3 plus number of force releases. Did I write 3? Did I write 6? Did I write 6? Okay, if I write 6, that is wrong. Okay. Yeah, you change it to this one only, right? You change it to that, right? Here 2 force releases only will be there, right? Not 3. Maybe by mistake I have written, but you check it. Okay. If you have written like that, it is wrong, right? That is wrong. Okay. Let me check yesterday's class. I'll check after the class is over. Okay. But this is only correct, right? This is only correct because we know the force releases has 2 now. So because of this introduction of this internal roller, what happens? What happens, you can say? Yeah. That's why you have to attend the classes regularly, right? Yeah. In the class when I have explained the force releases, nobody was there in the class, right? Nobody was there in the class, right? Okay. Force release means the member force, right? You will be having the member force now. So here if you just observe, right, what is that you are having? This is your rigid joint, na? Don't worry, I am explaining now. This is your rigid joint, na? So rigid member, how many member forces are there? 3 member forces are there, na? What are the 3 member forces now you are having? Tell me. 3 member forces are equal to which one? This one axial force, comma, one shear force, and one bending moment, na? Is that no? Is this point clear? Is this point clear now, Shruti? This member will be having the 3 forces. What are the 3 forces we are having? One axial force, one shear force, and what is another one you can say? One bending moment. Is that point clear or not? Yes, no? Now, what is that we are doing here is, suppose if you are introducing an internal hinge, what happens? What are the forces now? That member forces will become which one? That member forces, right? What will happen to the member forces now? The member forces will become which one? This axial force, and this is shear force only, right? It releases which one? This bending moment is 0. So bending moment is 0 means it is released, you can say, because internal hinge means bending moment is 0 at that internal hinge, na? So because of this introduction of this internal hinge, right, what happens? This internal hinge is making any one force 0, na? This internal hinge is making any one force 0 or not? Yes, this internal hinge is making any one force 0, right? So that arrangement is making which force 0, that you can call it as the force release. Got it now? Clear? Which force it is making 0, that is called as your force release, right? If it is making 2 forces 0, you call it as which one? If you are making it to 2 forces 0, right, what is that you can say? If you are making it as 2 forces 0, 2 force releases are 2. If it is making only 1 force 0, force release is 1, right? Now understood? Clear? The definition is clear? Right? Done, everyone? Right? Shall I move? So today's discussion that we'll be going for it. Today is what? 1st December na? So 1st December 23 I'll be discussing, right? I'll be starting which one? This is stability. Stability of these structures. So what are the stability of these structures? You can say, if you just observe, there are two different types of these stabilities you are having. So what is that first stability? External stability. External which one? Stability, right? And external stability or instability, okay? Instability, instability, all are same, na? So this is which one you can say, right? Second one, what is that you can say? Internal stability, right? Internal which one? This is stability or instability. Like that, okay? Just note this and tell me. We'll move on to the next. I'll explain, don't worry, what is that internal stability and what is that external stability. Once noted, tell me. Done? Right. Here if you just observe, right, what is that external stability? If you just observe, if structure as a whole will maintain position. So what is the meaning of this maintain position? Maintain position, then it is called as which one? This externally stable. What is the meaning of this externally stable? You can say, if it is maintaining its position, it is externally stable, right? Otherwise, what is that you can say? Otherwise, right, what is that you can say? It is externally unstable, no? Otherwise, what is that you can say? Externally unstable or not, right? Yes, otherwise externally unstable if you just observe, right? Otherwise, it is externally unstable if you just observe, right? Is not? Now, now, so here, if you just observe, otherwise it is externally unstable, right? Suppose if you just observe, right, what is that you can say? You are having a structure like this. You are having a structure like this. Now, whenever you are applying a load, it will stay here or it will be moving. Even for this small amount of load also, right? What will happen to this structure? This structure will be stable or unstable externally, right? It will stay in the same position. It will stay in the same position or it will be moving from one place to other place. Tell me. It will stay in the same position or it will be moving from this one place to other place, right? It will be which one? This is, yeah, it is only YouTube class, right? It is only YouTube class, you can say, right? Today no Unacademy special class, right? So next to two classes will be in YouTube, next to two classes will be in the which one? Unacademy app, okay, right? So what happens, you can say it will be unstable na? Why it is unstable? Tell me. Because if you are applying the load na, all are roller supports only. So what will happen? If you are constructing this beam in the a beam in which one? This Naveen's home, it will go to which one? This Captain Jack Sparrow's home na, is that na? And it will go to Shruti Lakshmi's home and Nagalakshmi's home, right? Everybody's home. Finally it will come to this RP sir's home, right? Is na? Like that. So here it will stay at one place or it will be roaming around the entire world. It will be roaming around the entire world, na? Is that no? It will not stay. If you construct this kind of structure in your place, na, it will go to some other person's place. So is it okay to construct this kind of structure or it is not okay to construct this kind of structures? Tell me, all of you. Is it okay to construct this kind of structures, or it is not okay to construct this kind of structures, everyone? It is not okay to construct these kind of structures, na? Okay or not okay? Yeah, because there is no resistance in this horizontal direction, right? Like that. Suppose if you are having, like this, right? What happens? Tell me now. Now tell me, this structure will move anywhere. This structure will move from one place to other place. If you are constructing this structure in Delhi, will it move to this Mumbai? Is it possible? This structure is stable or unstable? Tell me. So here horizontal reaction will be there, na? Here horizontal reaction will be there, vertical reactions will be there. Now tell me, this structure will be stable or unstable, everyone? So if you are applying the same load like a previous structure, this will move from one place to other place, or it will not move? Yes, it is stable, right? It is, which one? This is stable, you can say, right? Got it now? Because it cannot move, na? Right? It cannot move from which one? This one place to other place, right? It cannot move from which one? This one place to other place. Then you can say it as which one? This is stable, right? Like that. Is it clear? Is it clear? So the structure as a whole will maintain position, then externally stable. If it is not maintaining, otherwise if it is not maintaining the position, otherwise means if it is not maintaining the position, then it is what? Then it is unstable, right? Then it is which one? This unstable, you can say. Got it? Not like that. Structure as a whole, right? Structure as a whole, right? Even if you are trying to move one structure also, one part also, other part will allow it or other part will not allow it. Shruti, if you observe, one part is trying to move, but this left part is allowing or left part is not allowing the right part to move. Even though you are trying to move the right part, left part will be holding the right part, na? So left part will be holding the right part or not? Left part is holding the right part, right? So can we say it is externally unstable? No, you cannot say, right? Like that. Got it? Got it now? Now, what is it you can say? If, when you can say it is internal instability, if members not displaced, if members are not displaced by larger, yes, larger larger amounts comparable to members comparable to other parts of structures, then it is called with which name? Then it is called as which one? This internal stability, internally stable. Then it is called as which one? This internally stable, right? Otherwise, right, what happens? You can say, otherwise what happens? You can say if it is internally unstable. Internally unstable, right? Don't worry, you just note these points and tell me. I'll go on to the next slide and explain. Yes, Jack Sparrow, that must be satisfied. That is equilibrium condition. So if you just observe in the first structure, sigma fx0, no horizontal force is there, sigma fx0 satisfied, sigma fy0 satisfied, sigma m satisfied, but unstable. So what is that? What is the reason for that? Sigma fx0 only, na? There also, first one also, second one also sigma fx0, third one also. Everywhere that sigma fx0 satisfied. If equilibrium is there, na, then no movement at all, right? If equilibrium is not there, then only movement will occur. Okay, note this and tell me, everyone. Is there any effects? Tell me. Is there any horizontal forces? Tell me, Captain Jack Sparrow. Is there any horizontal force? Is there any horizontal reaction present? Now tell me. Yeah, yes, sigma fx is not 0, right? There is no horizontal reaction present. There is no horizontal reaction present. But still, I'm checking with the load application. But without a load also, what happens? Tell me. Without a load also, what happens? Tell me. It will stay in the position. Without a load also, whether you are considering the load or not considering the load, it is unstable only, right? It is unstable only. If I remove the load also, just by looking at the structure, you can say, yeah, yes, right? There is no horizontal reaction applied, only horizontal load there. But still, suppose if I am not applying any load, now tell me, if I am not applying any load, now tell me sigma fx is 0 or sigma fx is not 0, tell me here. No horizontal reaction is there, no horizontal force is there, so sigma fx automatically will become 0 na? Nothing is there means in the horizontal direction means what is there in the horizontal direction? 0. Still it is stable or unstable, you can say. Just by looking at that sigma fx 0, sigma fy 0, can we say my intention is what? My intention is what? That will be satisfied, okay, but just by looking at that, just by ensuring that sigma fx 0, can we say it is stable? No, it is unstable, na? Like that, okay. So equilibrium conditions will be satisfied, okay, equilibrium, but can we say, is it compulsory that, is it compulsory that, right, is it compulsory that, is it compulsory that it will be stable? No, okay. Just by equilibrium conditions we cannot say. Equilibrium conditions should be satisfied compulsorily, but at the same time, even all equilibrium conditions satisfied, we cannot say it is stable. That is what I am telling, okay. It is optional only but not compulsory, okay. Got it now what I am saying? Right, note this and tell me. Yeah, not compulsory. Yeah, not compulsory. So if equilibrium condition is satisfied, it need not be stable compulsorily. Okay, it can be unstable also. That is what. Got it? Note it and tell me, everyone. Note and tell me, all of you. I'll show the internal instability one, and then I'll explain the conditions for this internal conditions for the stability and instability and everything. Note it and tell me. Note and tell me, everyone. Now coming to this. So what is it we are having? Conditions for external stability. Yeah, I said I'll be showing that, but I forgot. Okay, one second. Internal instability, I'll show that example. So what is that you are having? If you just observe, this is your structure, let us say. Externally it is stable or externally it is unstable, tell me. Just by observation, whenever you are applying the loads, right, will it move from one place to other place, or it will not move from one place to other place? It will not move from one place to other place, no? Will it move or it will not move? It will not move, no? Now tell me, suppose if there is an internal hinge is there. There is no internal hinge, right? What will happen? Even for chota bacha load 0.00000000001 load also, what will happen? It will be subjected to this falling like this, no? Collapse. As a structure it is moving or entire structure is not moving, tell me. Entire structure it is moving or entire structure is not moving, tell me. Entire structure is not moving, na? Yes or no? Entire structure is not moving, right? But what happens, you can say, entire structure is not moving, right? So it is externally stable or externally unstable, tell me. Externally, first one is stable externally, na? Second one is also stable externally, na? Internally, tell me. First one is stable or unstable, right? Yes, first one is stable. Second one, internally, right? When you can say it is internally unstable, when you can say it is internally unstable, if you just observe. Yeah, tell me, second one internally stable or unstable? Second one internally stable or unstable, everyone? Second one internally unstable. Why? Do you observe this? If a members are not displaced by these larger amounts comparable to the other parts, then they are stable. But here they are moving by large amount comparable to the others. So they are moving by large amount, then you can say it is internally unstable, right? Like that. Got it? Understood? So simply what is that you can say, if any force release is present, right? If any force release is present, if any force release is present, any force release, right? What are the force releases? You will be having the internal hinge like this, right? And also what is it you can say? These sleeve type of this force release, right? And what is that you can say? This kind of one. And what is another one you can say? This kind of one is present. And also what is it you can say? This kind of one is present, right? So if any force release is present, right, what happens? It is internally stable or it is internally unstable. You can say, if you just observe it, any force release will result in this collapse now, it will become internally unstable, right? Got it now? So simply by looking at that, you can say if any force is released, then you can say it is internally unstable, right? Directly you can write it. Okay? Is that clear? Right. Now conditions for external stability. So what are the conditions for this external stability? You can say first one, sufficient number of support reactions. Sufficient number of which one? This support reactions. Right? Sufficient number of support reactions, right? That is first condition. So sufficient number of support reactions means it should be greater than or equal to 3 for what? If it is a plane structure, that a number of reactions, right? And that number of reactions should be greater than or equal to 6 for which one? This is a space structure, right? Because three equilibrium equations are there, means three equilibrium conditions we have to maintain. For maintaining the three equilibrium conditions, minimum how many reactions we should have? Minimum 3 reactions we should have, right? That is required. But is it only sufficient enough? No. Along with that, other conditions also must be satisfied, right? We'll see what are the other conditions also. First we have to check this, right? Sufficient number of reactions are there or not, we have to check it, right? Okay, if a sufficient number of reactions are there, right, they must be all reactions. Must not be which one? All reactions must not be which one? It should not satisfy which conditions? You can say all reactions must not be parallel. Second condition, only sufficient number of reactions are okay, or they must not be parallel. They must not be parallel, and they must not be which one? This concurrent, right? What is the meaning of this concurrent? They must not be parallel means parallel to each other like this will be then. Concurrent means all are meeting at a point, right? If all the reactions are meeting at a point, then you can say it is a concurrent, isn't it? So non-concurrent and non-parallel, right? So they must not be parallel, then they must not be concurrent, you can say, right? Got it? Not parallel and should not pass through the same point. Yes, yes, yes. Concurrent means passing through the same point. Non-concurrent means right. Note this and tell me. Done, everyone? Right. So third one, DSE, right? What is a DSE? external static indeterminacy must be greater than or equal to which one? This is 0, right? External static indeterminacy must conditions, right? What is that? You can say must and should conditions, right? Must conditions means only one condition should be satisfied, or all conditions must be satisfied, right? All conditions must be satisfied, na? Right? All must conditions for external stability, right? All must conditions for which one? This external stability, right? Only any one condition satisfied, it does not matter, okay? All we have to check it. If all are satisfied, then only it is possible, right? So what is it? You can say all must be satisfied, right? DSC must be greater than or equal to 0. That is, what does it mean? That means if a DSC is lesser than 0, then it is externally unstable or externally stable. Externally unstable, definitely. Okay, got it now? Right. Again, what is another one you can say? What is another condition satisfied? Tell me. What is another condition satisfied? Tell me. DSI, that is for internal. So still this is we are talking about which one? This is we are talking about which one? This is external. All must conditions for this external stability, na? So external stability, na? Is that no? No sinking of supports, right? If there is a sinking of supports, right, they will be stable or unstable, you can say. They will be stable or unstable if the structure is subjected to this sinking. If the structure is subjected to this sinking, it will be stable or unstable, right? It will be which one? This is unstable only, no? Sinking of support means entire structure will be moving, no? Yes or no? One part will be moving with respect to that. It is unstable, definitely, you can say, right? Now, what is another one you can say if you just observe? All must conditions for this internal stability, right? Which one are the conditions for internal stability? First one is what? Sufficient number of members. What is the meaning of this sufficient number of members? Sufficient number of members is what? M is greater than this 2j minus 3 for what? Trusses. And that M should be greater than which one? This is for this plane frame, na? Is that no? So what does it mean? You can simply just observe. What does it mean? You can simply just observe. That should be, that means that DSI, internal static indeterminacy, should be greater than or equal to 0. Either determinate or determinate means indeterminate, right? Suppose what does it mean? You can say, right, that means that, that is, if a DSI will be lesser than 0, right, what is it you can say? If a DSI is lesser than 0, it is internally stable or it is internally unstable, you can say. If DSI lesser than 0, it is internally stable or it is internally unstable. If you just observe, right, it is internally unstable, na, definitely. Internally unstable, you can say, right? What is another condition? No force releases, right? No FR, right? What is the FR? Force releases should be present. No force releases should be present, right? If any force release is present, if any force release is present, what is that you can say? It is internally unstable only, no? Now, what is it you can say? Sufficient number of members will be there, right? Sufficient number of members will be there, right? But still what happens, you can say? geometrically all members will be held in position. So means there must not be geometrical instability you'll be having, right? Okay. Now this one tell me. Now to tell me. That is for rigid joints only. Need not be. That is deformation, na? Captain Jack Sparrow. That is deformation. Yeah. Yes. Yes. 3M, na? That is for which one? These deformations. Deformations you can have no problem. When angle between the members is changing means rotation is there. Rotations, horizontal deflection, vertical deflection, rotation you can allow no problem. But one member moving from its location by large extent, na, that is not allowed. Okay, got it? Yes, yes, 3M for this plane frame, because each member will be carrying how many member forces? Tell me. That internal indeterminacy I have given the equation, total indeterminacy I have given the equations now. And the class which everybody was absent. Not this and tell me. Right, done everyone? Done everyone? Right, okay. So we'll be going for the next one, right? What is it you can say? All members placed in proper position, right? What is the meaning of this proper position? To satisfy what? To satisfy which one? This is stable configuration, na? To satisfy which one? This is stable configuration, right? Suppose for example, if you just observe, what is it a number of members? Tell me here. One second. Now tell me how many members are there here? Good afternoon. How many members are there here? Tell me in this first one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? 16 members are there, na? 16 members are there, right? How many joints will be there? So these are not joints. There, the members are just crossing each other, right? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, right? 8 joints are there, na? Yes or no? Now tell me, what is that you can say? Is that m greater than 2j minus 3? What is the relation between this m and 2j minus 3? M is the number of members are 16. 2 into, right? What is that you can say? 8 minus 3, right? How many are there if you just observe? Tell me. Number of members are 16, right? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, 16 members. How much it comes to be? Exactly 8. What is that you can say? 16. This is which one? 2 into 8, 16. 16 minus 3 will be what? 13, right? It is satisfied or not? It is satisfied, right? For this also, number of members will be how much? 14. Joints will be what? 8. Now tell me, here m, what is it satisfied? M and 2j minus 3. 14 members are there, and it is which one? This how many joints? Same number of joints, na? 2 into what is the number of joints? 1, 2, 3, 4, 5, 6, 7, 8, right? 8 joints minus 3, right? 14 is greater than this this 13, na? So for this second one also it is satisfied, na? For both it is satisfied, but can you tell me both are stable or unstable? This is internally, which one this is stable? This is internally stable or internally unstable? Second one, tell me everyone. The second one is internally stable or internally unstable? Tell me. Tell me for the second one, only the members are sufficient or they must be placed in a proper position. That is important. It is internally unstable, na? So only sufficient number of members present is enough, or they must be present in the proper position is also important? Tell me. Only sufficient number of members present is important, or they must present in the proper position is also present, right? One member is not in the proper position, na? So no, one member is not in the proper position or not? Yes, right? Suppose if you are making it like this, right, what happens? You can say, so this part will be unstable, na? This part is second panel will be unstable, na? This is second panel is unstable or not? This second panel, middle panel is unstable, right? So for trusses, to maintain the stable configuration, right, what is that we have to maintain? Simple triangle shapes we have to maintain, right? Here triangular configuration is not there, means truss will never be stable, okay? Truss can never be stable if triangular configuration is not there, okay? Note it and tell me everyone. Like that, is a clear everyone? Stability, instability, how to identify? Got it? One diagonal is also present, it is okay. Yes, yes. Naveen, one diagonal is also present, it is okay, no problem. Suppose if you are having a structure like this, now tell me. It is stable or unstable? Tell me. It is internally stable or it is internally unstable? Tell me this diagram. This diagram is internally stable or internally unstable, everyone? It is internally stable, na? It is internally stable, right? How many number of members you are having for this? Tell me. Yeah, what is that number of members you are having, right? That number of members will be 13 only, no? So equal to that 2j minus 3, no? 13 equal to that 13, right? So m is, you don't even have extra member, but this one if you just observe this second structure, it is having that extra member, but still it is unstable, right? Only having the extra members is enough, or placing them in a proper position is also important? Tell me. Placing them in a proper position is also very, very important. Na? Yes, placing them in a proper position is also very, very important, right? Only sufficient number of members is enough, or placing them in a proper position is also important, right? Placing them in a proper position is also important. Got it now? Got it now? Understood, everyone? Is that clear, all of you, everyone? Yeah, just having more than the required numbers is not enough. Not only enough, right? That is required definitely. You need to have number of members equal to the required or slightly greater than the required. That is required definitely. Along with that, placing them in a proper position is also very, very important. Okay? Right, noted. Once you want to tell me, we'll try to move on to the next. So we'll go for the questions now, right? Shall we go for the questions, everyone? We'll go for the questions now, okay? Now tell me. Before going to the questions, right? Shall I go for this shortcut method? One shortcut method, open cantilever tree method. That closed boxes method I have mentioned already in the previous class. You just check the previous YouTube class or whatever it is the class. Only 16 minutes class will be there. Right, you check that closed box method I have explained. I will not be explaining again now. Right, you have to check it. And what is that another one? Open cantilever tree method. So what is that open cantilever tree method? If you just observe here, if you just observe, what is that you are having? So now tell me, it is stable or unstable? Three number of reactions are there and they are all the reactions are collinear. No, no. One is moment reaction, right? It is stable, na? It is stable, right? Open cantilever tree. Open cantilever tree is which one? Is stable. Is stable and determinate, na? Open cantilever tree is what? Stable and this determinate or not? Yes, it is stable and this determinate, right? So now, if not open, right, what is it you can say? If not open means, right, what is it you can say? Number of member forces are higher, na? If not open, right, member forces plus this reactions will be, what is that you can say? If not open, member forces plus this reactions together, they will be greater than which one? Member forces and reactions together, they will be greater than the number of equilibrium equations, no? Number of equilibrium equations, right? So what we need to do, if you wanted to make it a determinate, what we need to do? We have to convert this non-closed one to this closed one, na? So for converting that, how many forces we have to release, right? If you just observe, for example, I'm taking, for example, I will show all of you. This is your, which one you can say? This is a structure, okay? Now tell me, what is the DS you can say for this structure, everyone? 3m plus r minus force releases, na, sum of the force releases, right? 3m plus r minus 3j, na? 3m plus r minus 3j. 3m plus r minus 3j minus sum of the force releases. Is there any force release you are having or no force release? No force release, na? So 3 into how many number of members are there? Tell me. How many number of members are there? How many number of joints are there? How many number of reactions are there for this? Tell me. All of them. Here vertical, horizontal and this moment reaction at this place also 3 reactions. 6 reactions are possible. How many members are there? 3 members are there. Joints 1, 2, 3, 4, right? 4 joints are there. So 3 into 3 plus number of reactions are 6 minus 3 into how many joints are there? 4, right? Tell me what is the degree of this static intermittency? Tell me what is the degree of the static indeterminacy? 3 into 3, 9. So 9 plus 6 minus 12 equal to how much? 3. So ds, degree of static indeterminacy is how much you can say? Degree of the static indeterminacy is how much? 3 na? Now ds you can say it as 3 na? Now to convert this into that open cantilever, right? This is indeterminate or not? This is indeterminate na? Okay. 1 second. This is indeterminate. Okay, okay, note it. So this is determinate or indeterminate? Tell me. This is indeterminate by this degree 3 or not? Yes, this is indeterminate by this degree 3 you can say is na? Okay, note it and tell me, Shruti. I'll wait, don't worry. Note and tell me. Done? Okay. So now to convert this to determinate, open cantilever is determinate and stable we have mentioned. Na? How can you convert that if you just observe? If you are cutting at this place, right? Once if you are cutting at the center, na? Once you are cutting at the center, right? Suppose if you are cutting at some position, what happens you can say? Whenever you are cutting it, right? Cutting means how many forces you are releasing, how many forces you are removing? 3 forces are removing now. So because each member will be having which one? Each member will be having this one force now. Each member will be having the 3 forces. Sorry, each member will be having the 3 forces now. So by cutting we are removing the 3 forces, right? So by removing the 3 extra forces, right, we are making it determinate, right? So to make it determinate, right? To make it determinate, right? How many member forces we have to remove it, right? How many member forces we have to remove it, and also, right, what else you can say? To make it determinate, how many member forces we have to release it and how many reactions we have to add it, right? So that ds will be equal to 3c minus sigma r dash. It is not r, it is r dash, minus which one? This is sum of the force releases. Okay, this is the degree of this static indeterminacy, right? So what is that? C, number of cuts. Okay, number of cuts made to convert what? To convert a frame to what? Into open cantilever. So open cantilever means that a support must be fixed support or hinged or roller is also allowed. Convert a frame into which one? This open cantilever, right? Open cantilever means that support must be fixed. Now support, if we, suppose if a fixed support is not there, right, what is that you can say? You can say it as which one? This you can convert that into fixed now. So that is sigma r dash. So what is it? You can say number of reactions added. Sigma r dash is nothing but number of reactions added at supports number of reactions added at supports for which purpose? To make all supports as fixed. Noted, tell me. This one you just noted, tell me everyone. I'll show one example for that purpose. Done this one everyone? Right. Suppose if you just observe, right, what is there you are having, right? One support is there, right? This is hinge support is there. This is a roller support is there. So what we need to do here, we have to make one cut, na? One cut we have to make it, right? So number of cuts equal to 1. And here to convert this into fixed support, right, how many reactions we have to make it? So we already 2 reactions are available. To convert fixed, right, what is it you can say? 2 plus 1 reaction we have to add it, na? Here also 1 reaction will be there. To convert that into fixed, plus 2 reactions we have to add it, na? So number of cuts equal to 1, is na? Number of cuts equal to 1. Sigma r dash will be equal to which one? This is plus 1 plus 2. Yeah, for both. Plus 1 plus 2, right, what is it you can say? 3. Therefore, that what is the degree of the static intermittency? 3c minus sigma r dash minus sum of the force releases, right? No force release is there, you take it 0. 3 into how many cuts? 1 cut minus how many are added? 3. What is it you can say? That ds will be equal to 0. Now check it by the formula. Are you getting the same thing or not? 3m plus r minus 3j minus sum of the force releases. Do you have any force releases in this member? Do you have any force releases in this member? No force releases in this member. No force releases, na? Sum of the force releases 0. Number of members will be how much? 1, 2, 3. Number of joints will be how much? 1, 2, 3, 4. How many number of reactions you are having? Tell me. Number of reactions at this place 2 reactions, at this place 1 reaction, at 3 reactions you are having. Okay. So what is the ds if you just observe? 3 into how many number of members? 3 plus number of reactions are 3 minus 3 into 4. How much it comes to be? 9 plus 3 minus 12. That is 12 minus 12. How much it is comes to be? 0. Now this formula is verified or not? Now this shortcut formula is verified or not, everyone? Now we can verify this shortcut formula, na? Is it clear, everyone? Now we can verify this shortcut formula, right? We don't have any problem using this formula. Is it clear, everyone? All of you. Is it clear, everyone? Right. Note this and tell me. I'll just do some 1 or 2 examples and I'll close the session. Note this and tell me, everyone. Done, everyone? Right, now tell me. Tell me if this structure is a stable structure or unstable structure. Tell me, everyone. This structure is a stable structure or unstable structure? This structure is stable or unstable, right? So tell me. 3 structures I'll draw. Okay, 2 I will draw. First one is your stable or unstable, tell me. How many number of reactions are there? How many number of reactions are there? This is 1 reaction. These are the 2 reactions. So number of reactions equal to 3. That is satisfied. Okay. All are concurrent or not concurrent, right? So these 2 forces are meeting at a point, but is that a third force meeting at a place or not meeting? All, right? Naveen, you have to be careful, right? What I said, all must be non parallel, right? Non parallel. If any one is non-parallel, okay, accept, right? Non-parallel, non-concurrent. Non-concurrent, right? Because all forces are meeting, all the reactions are meeting at a place, or all the reactions are not meeting at a place. All reactions are not meeting at a place. Now only these two reactions, two reactions are meeting at a place, right? So can we say it is concurrent or non-concurrent, right? These are non-concurrent only, no? Non-parallel, non-concurrent. So then they must be stable or unstable. Then it must be stable, you can say. But this one, number of reactions are how much? 4. This is unstable, right? Why it is unstable? If you just observe the resultant reaction coming from these two, right? What is it? You can say that the resultant reaction of these two, the resultant reaction of these two, they will be meeting at a place now, because they are which one? This concurrent now. Because they are concurrent, it is stable or unstable? That is unstable now. Is it clear? Right. So note this and tell me. I'll close the session. First one is stable, second one is unstable, right? You have to be careful. Don't worry, tomorrow or next class, whatever it is, mostly tomorrow we'll do it. Tomorrow what we'll do is, tomorrow either I'll do this highway class or I'll do this one. But the next class of this one, questions only we'll do, right? First, second chapter questions we'll do, okay? Static indeterminacy, kinematic indeterminacy and basics. Based on these questions we'll solve, okay? Right. Note this and tell me. No. It will allow. Will it allow it? No. Even bottom support roller also it is stable only, right? Because will it allow it to entire structure will be allowed to move? Now when you have to check it, entire structure is moving or not moving. That you have to check it. Okay. Suppose if entire structure is trying to move the downward, this reaction will be applying. Na? It cannot allow. Na? Where is concurrent? Tell me. Only 2 forces are concurrent. Na? 3 forces. Okay. You are saying that top roller, bottom also roller. Are you saying that? Are you saying like top roller and bottom also roller? Are you saying that? Are you saying that, Naveen? Top and bottom both are roller? Then it is unstable. Yes. Then it is unstable. Yeah. So here because this reaction. Now only 2 reactions are there. Both will be meeting at a place. So what is it? You can say number of reactions are 2. That is lesser than 3 and concurrent. So from this itself we can say that it is unstable, right? From this itself we can say that which one is unstable, right? Why? Number of reactions will be lesser, no? Number of reactions will be lesser, right? Okay? Thank you. Thank you all of you. Have a good day. Thank you.